Eighth graders, it's week 12 and we're talking about waves. Last time we talked about transverse waves. Today we'll be talking about longitudinal waves. So we should be able to explain how longitudinal waves work once we're done. You've probably played with one of these, a slinky. They're simple toys, but they can move in very interesting ways. Pushing on one end of the spring toy, for example, gives it energy that moves through the spring in a longitudinal wave. A longitudinal wave is a type of mechanical wave. A mechanical wave is a wave that travels through matter called the medium. In a longitudinal wave, particles of the medium vibrate in a direction that is parallel to the direction that the wave travels. You can see this here. The person's hand pushes and pulls on one end of the spring. The energy of this disturbance passes through the coils of the spring to the other end. Notice that the coils of the spring first crowd closer together and then spread farther apart as the wave passes through them. Places where the particles of a medium crowd closer together are called compressions. They're compressed, squished together. Places where the particles spread farther apart are called rarefactions. The more energy the wave has, the closer together the particles are in compression, and the farther apart they are in rarefactions. P waves are longitudinal waves caused by earthquakes, so in rock. This disturbance that causes an earthquake sends longitudinal waves through underground rocks in all directions away from the disturbance, just like we saw with dropping a pebble in the water. But P waves are more like what we see in this model here. Instead of up and down motion, there are compressions and rarefactions. So, where are the compressions and rarefactions of the medium in this model of P waves? The medium is rock. Where are the compressions and rarefactions of the medium in this model of P waves? Pause the video if you need extra time to answer this question. You already know the answer? That's awesome. Let's go on then. The compressions are the places where the vertical lines are closest together. The rarefactions are the places where the vertical lines are farthest apart. So if we were to summarize, we'd have to say that a longitudinal wave is a type of mechanical wave or a wave that travels through matter called the medium. In a longitudinal wave, particles of the medium vibrate in a direction that is parallel to the direction that the wave travels. So it's going in the same direction as the direction of the wave. Places where particles of the medium crowd closer together are called compressions. Places where particles of the medium spread farther apart are called rarefactions. Earthquakes cause longitudinal waves called P waves, which pass through underground rocks. So, at this point, could you explain longitudinal waves to me? I hope so. If not, feel free to go back to the video. And if you can, move on to the next assignment. We'll see you on the other side.